Hello, I'm Chris Steele. I'm a noise and vibration inspector with the HSE. When I started with the HSE, an old inspector, she told me that people only really want to see one thing from an HSE presentation, and that's not the last slide as quickly as humanly possible, but actually they just want to see real life examples of what good and bad look like. So I'm going to try and do that for you and try and explain what our position is. So the first one's called What Have You Actually Designed? I'll start off just by showing you a thing called a phonograph, which I'm sure you're aware of, arguably the first mechanical device designed to reproduce sound. And it's got a big horn to amplify noise. It's got a rotating cylinder that vibrates against a needle. And then it's clamped down to a nice big resonating box. And at this point, you're probably thinking, why are you showing me a phonograph? Well, you go to site and you come across a thing called a granulator. It's arguably the best way to break up wood and timber. This model produces 100 dB even when there's nothing running through it. And it's a big horn to amplify sound, rotating against a cylinder that causes vibration, and it's clamped down to a nice big resonating box. So you can see that there's a bit of a design correlation between these two things, which you find frustrating. It is possible to design granulators so that they don't make so much noise. Hopefully some of the speakers today will help you understand how you go through that process. But what I find frustrating as an HSE inspector is when I go to site, say a food production site, and the guy has to ask himself the question, am I buying a potato masher, that's an industrial scale potato masher, or have I bought an air raid siren? Because the two of them follow exactly the same design principles. They both make a very high-pitched whining noise over 100 dB. The only difference is that you shove tatties through one of them. Noise control needs to be considered at all stages of the design and development of tools and machinery. That's our expectation within the HSE. We expect people to think about noise when they're designing products. So if you're making things which follow the same design principles of things which make noise, you really should be thinking about what you can do about it. Second one's called we didn't think that would be a problem. This thing here is a static concrete mixer. It makes batched concrete and mortar in a factory setting. Concrete residue builds up between batches, so lots of hard concrete on it, and then it has to be broken off by a power tool. So somebody has to climb inside into a big metal drum and hit the side of the metal drum that they're inside with a mechanical hammer. What do you think the industry solution to that is? The industry solution to that is a safe system work protocol. And a safe system of work protocol looks like this. Someone gets in it, except before they get in it, they sign a piece of paper saying that they're going to follow a 6-page document that they haven't bothered to read. Yes, it's noisy. There's also issues of being crushed, having your head crushed, having your foot lost, and fatalities. How, you may ask? Well, the guy doesn't really want to get out to get into the next side past the starters. So what he does is he has someone outside quickly switch it on and switch it off so he gets pushed round to the next bit to clean off. And we've got MSD risks and halves risks and dermatitis risks and silica risks. And Tau, who's sitting there, hi Tau. That's the best wave you could do, Tau? That's better. Right, Tau said to them, maybe the solution to this is, well, what do you think the solution to this would be? I don't know if you've ever walked past a construction site at 4 o'clock in the afternoon. You'll see a guy with his thumb over the end of a hose washing out the small concrete mixer. Maybe we could put some hoses in there, and that will eliminate or reduce all those risks and reduce downtime from 2 hours to 10 minutes. So that seems like a pretty good thing, doesn't it? Designers and manufacturers should aim to minimise the noise likely to be generated under all reasonably foreseeable uses. Now, we could probably have an argument about whether or not the manufacturer should see it as being reasonably foreseeable that concrete would go hard. I would argue that he should, but you would be amazed at the amount of machinery we come across where the noise level stated for it is not the machine actually in use. Granulators that aren't granulating, wood chippers that aren't chipping wood, lawnmowers that aren't cutting grass. It's reasonably foreseeable, if you're making machines, that you should be providing noise data on them that shows us how much noise it's going to make while it's working. Number 3 is called what a coincidence. This is a typical workshop vacuum cleaner. As it gets older, more and more noise comes out of the bush that's holding the motor shaft, which is frustrating. It starts to make a horrible grinding noise, it gets really noisy. What's frustrating about that is you can't find a bush to replace it because it's not a standard product. So instead of spending 5-10 pence on a bush, you have to go out and spend 40 pence on a bearing. And what's really, really annoying is when you find that the bearing that you've bought fits into the receiver. It's an absolute perfect fit, which would then make you assume that the manufacturers of this at some point have said we could save a bit of money by taking the bearing out and putting in a bush. Manufacturers are legally required to ensure that machinery is designed and constructed to reduce risks from noise to the lowest level, taking account technical progress. I don't think in 2019 it's too much to expect that somebody should be using bearings in a piece of equipment. You may have a different opinion. I don't know. We might find out. If you're buying machinery and you don't think any of these three things are being undertaken, they're not thinking about the design of it at the start and how that can affect the noise, they're not thinking about foreseeable noise risks, and they're not using techniques which are available and already in use, what do you do about that? Well, please come and tell us about it. Tell the HSE about it. We have a concerns page, not the complaints page. That's where people complain about me. Please don't go to that page. Go to the concerns page and tell us if you're coming across machinery that you think is noisy and should be quieter. And if you want to avoid buying stuff that's noisy, then if you go outside, there should be about 50 sets of these things here, this Nomad Machinery, Noise Machinery Directive Buy Quiet advice, which gives companies an idea of what they should be asking whenever they look at buying new machinery and equipment. Okay, number 4, why are you doing that? Now, some of you may have seen this. I put this up on LinkedIn. It's a guy using a compressed air gun to blow down small amounts of dust. Apologies to Sullivan, I'm not going to steal your thunder here, but I shoved this up, which is, if you remember the classic spot the ball process, the idea here is this is the audience participation part of the talk. This is where you have to shout out where you think on this photograph the way of controlling the noise that has been created. Where do you think it is? Come on, someone say a number. F6, F7, C4. What's C4? That's where the noise is. I'll show you where the noise control is. It's there. It's under the desk. I don't know if you can see that. That is a feather duster. If you want to give it its technical term, it's a microstatic duster, and it just picks up the crap that's on the top of that bit of wood there. Now, I asked them, why are you blowing it down with an air gun that creates 95 dB when you could simply just give it a quick run over with a feather duster? And the response was, well, we were using it, but it gets dirty, so what are we supposed to do when it gets dirty? To which I said, I don't know, what do you do with your underwear when it gets dirty? And the answer is not turn it inside out, it's you wash it. I'm showing you that because there's a real expectation that there should be a hierarchy of control, and the HSE expect people to start at the top. Let's try and eliminate the noise source or the problem and then work our way down through engineering controls. Sadly for us, what we tend to find is that people do this. Let's just look at PPE. If you're making machinery or the manufacturers of machinery are sending you through products and all it's got is a sticker on it saying, yes, it's noisy, we are ear defenders, and they don't tell you how noisy it is, that's a problem. Right, question I get asked all the time, what is it the HSE want us to do? What does HSE actually want? Okay, well, if I knew the answer to that, I probably wouldn't be doing these talks, I'd be a multi-millionaire. But essentially, what the HSE wants is just two things. We want people to understand the level of risk and exposure, and we want them to focus on control. And if you only have the energy to do one thing, then it should be to focus on control. The concern that we have at the HSE is that we believe we're in danger of putting machinery noise into the too difficult box. Now, I'm guessing quite a lot of you are IOA members that are here today. The thing that frustrates the life out of me about that is we didn't put other aspects of noise into the too difficult box. You know, when I started working in acoustics, about 80% of all floors and walls in new build houses were failing. We're now getting pass rates of about 90% because of things like robust details, because of things like compulsory testing. We raised the awareness of that issue as an organisation. We can't really argue that the cost is too much. If you look at new road construction, happily putting in barriers now to get reductions of 4 or 5 dB. No one bats an eyelid at the cost of that type of stuff. Really can't make an argument that the criteria that's been set by the HSE is too stringent, because my God, if you're running a pub or a bar and you're trying to achieve inaudibility, that's a pretty tough criteria to achieve. And I don't think there's a reasonable explanation to say it's too complex, it's too difficult to understand what's going on, because, oh my God, look at the amount of stuff that we're doing now in terms of noise modelling. When I started work, noise modelling used to be a calculator and doing some distance attenuation on the back of a bit of paper. It's now multicoloured maps showing multiple sources doing multiple things. Right, what are we going to see today? The speakers that you're going to get in the afternoon are generally people from industry. Some of the stuff that they're going to present to you, you might have seen before. Some of it might be entirely new to you. You may be asking yourself, why am I seeing things that are well-established noise control? The reason why you're seeing these things is because the HSE inspectors just don't see it on site. There are products in the marketplace that have been about for over 30 years, and we're still finding sites where they're not being used. Also, the awareness of new things that are coming out is pretty low. You're also going to hear from Peter, who's going to talk to you about actual practical noise control and ask you some questions and see if you can work through problems that you actually have yourself. When Sarah gets up to talk, she is, I know she hates me calling you an ambulance chaser. Yeah. She's not an ambulance chaser. She deals with the civil side of noise complaints. She'll give you an indication of how big the scale of the problem is. I've got Joel here. Hi, Joel. From the Drilling and Sawing Association. You might be wondering, well, why have we got somebody who's from a construction background here? Well, the reason why the Drilling and Sawing Association are here is because they've looked at that hierarchy of control and said, what can we do to change the way that we work and make it so that we're reducing a range of risks, not just noise. And we've also got RMS, hi Julian, they're here today to talk to you about this idea of the kind of measurement and monitoring work that they're doing that can lead to practical improvements, not just for noise, but also for a range of other issues. I'm going to leave you with this slide. This is the HSE's aspiration. This is on our website. It's to eliminate by 2030 as an occupational disease new cases of noise-induced hearing. I am very sceptical that we will achieve that. I would like to think that maybe we could, but I think we probably need to start here and now. This is the point at which we need to start making more of an effort as the noise industry or the acoustics industry to deal with these problems.